actually make us live for a sec. Hello, everyone, and welcome to this, which is our third seminar in our Netherlands Astronomy Equity and Inclusion Committee seminar series. And we're very pleased today to have with us Dr. Jason Nordhaus, who's a theoretical astrophysicist and assistant professor of physics at the National Technical Institute for the Deaf, NTID, which is part of one of the colleges of Rochester Institute of Technology and one of the main institutions for deaf education in the world. Jason's committed to increasing participation of deaf individuals in physics. He has involved a lot of deaf students in research work also. And before joining RIT, he was an NSF Astronomy and Astrophysics Fellow and a postdoc fellow at Princeton. And he got his PhD from the University of Rochester in 2008. So I'm very happy to have Jason here today. And he'll be talking to us about removing barriers for deaf participation in STEM fields. Jason said that he's happy to have questions as we go along, and also we'll have plenty of time at the end, I think, for questions. Also, if you're watching the live stream on YouTube, you can type into the YouTube chat, or you can type into the chat in Zoom, and we'll get the questions from there to Jason as well at the end of the talk. So without further ado, I'll hand over to Jason.
Thanks, Jake. So I thought I would start, I start typically talks like this by saying some things about myself, because culturally, in the US at least, the deaf community is very tight-knit. And so if you met a deaf person for the first time, it wouldn't just be like, hi, my name is. You'd actually sort of talk a lot about your background, your family, sort of things that I think like the hearing community would think are might personal, but sort of share a connection. And so Jake did a great job already talking a little bit about my background, my educational background, and I thought I would share a little bit more information on how I got involved in this, and I'm happy to do so at the end of the talk too, or with questions. But I first sort of became interested in sign language, American Sign Language, when I was a postdoctoral fellow at Princeton. And at the time, I was sort of looking for something to do to offset the science work I was doing, because it's good to stay balanced, I think. And I was traveling somewhere on the other side of the world. I think it was either New Zealand or Australia. And I was at an airport and I saw two people just signing, and my flight was delayed. And I sat there and sort of watched them for like an hour thinking oh my God, this is like so amazing, so beautiful. I didn't realize it, but that's like a horribly rude thing to do. But it just happened, and it got me thinking on the flight back. I started thinking like, do I know any deaf astronomers? Do I know any deaf physicists? And I didn't, but when I got back to Princeton, I started looking into this issue and could find like almost no examples. I found some examples from the turn of the century that I'll talk about a little bit later, but sort of you can do this sort of thing where you ask how many there should be in the astronomy and physics community, and then there are very few, if not numbers on the order of one or maybe two, when there should be much more. Many more. So anyway, so I got interested in it, and I said, well, this is so cool. Like, I want to like learn how to sign. And New Jersey, Princeton is actually right near Trenton, which is the capital of New Jersey. And in Trenton, there's the Katzenbach School for the Deaf, which is New Jersey's K through 12 school for deaf and hard of hearing students. And it was great because they actually offered night courses for adults. So I just started going there and took classes there and picked up the language over several years. And I was lucky enough to win a National Science Foundation postdoctoral fellowship. And that brought me to RIT, where you get fully immersed in it, in the culture and the language, and you're doing it every day. And your language skills just take off at that point. And so as part of a postdoctoral fellowship here, I, at the time, NTID, the National Technical Institute for the Deaf here, didn't have any astronomy courses. So I developed the first one and taught that starting in 2013 and joined the faculty then. And I've sort of been doing this ever since. So I'll talk a little bit more about that in depth, but I did want to give you some background on myself. I'm hearing, but I'm immersed in the deaf community here and part of the deaf community. I also wanted to say that what I do talk about here applies just to the US. So, it's culturally to the US and American Sign Language. And so some of this stuff might translate to to other deaf communities across the world, but some of it may not. And I'm not an expert on that. So I can't say anything about, you know, the Dutch deaf community, for instance. But so this is all for the US. Okay, the other thing I like to do when I give talks like this is I like to have it be a little bit more interactive. And so I think the first thing I was gonna have you guys do, and we'll just take a minute to this, let's watch this video here. And then I want each of you to try to like explain this with your hands. So if you have to turn your voice off and you can't say anything at all, you can only use your hands, how would you actually communicate this concept to someone? And this is a familiar concept of cell division, and so most of us, you know, sort of know what it is, but you can see some movies here of cells dividing. And so let's just take a minute, watch this video, and I want to take a minute or two and have everyone just at least think about or try to convey this concept with just their hands. Maybe I'll stop it right there. Okay. So let's think about like how we might do that. And you don't have to show me, it's fine. I don't need to actually see it. I just want some people to think about it and think of like what are the challenges in doing this. Yeah, actually, that's great. That's great. Right. So you're already picking up on something, right? Which is that shape is very important. And so in ASL, these are C hands, and so like you're showing a circle here, and then you're actually showing the movement to it and the vision here. So like already you're sort of matching what you're seeing on the screen with your hands to indicate shape and flow and movement, and that's sort of the right-ish thing to do. One of the things I'll discuss a lot in this talk is that in order to accurately convey information, you need to understand the concept, and then you need to convey it in a conceptually accurate way. And there's a lot of different ways one could go about doing that, but that's a key thing here. Sign language, of course, is very visual. If you have like sort of the basic building blocks of the language and you're familiar with the language, when you see these like native signers really like, they're extremely fluent and beautiful. They almost just paint pictures with their hands. It's almost in some ways you don't need to necessarily know every particular sign to get the overall image or the idea of what's going on. And so this is a good example of that. Shape is important, how the movement happens, the division into two, the maintaining of the shapes afterwards, all very important. Now, let's read this, and I'll give everyone 30 seconds here to read this. All right, so this is a passage from a Nature paper on mRNA vaccines that I just found. But now, how would you do this with your hands? I don't have a good answer. I can't tell you. Part of the problem here is I have no idea what the sentence means. I have some vague, you know, there's parts of the sentence that I have some guesses as to what it might mean. There's portions of this sentence that I have absolutely no idea what it means. And so if my job is then to interpret this or to convey this to a student as an interpreter, you actually have to understand what this sentence means. You need to know the concept to actually convey the information to a student or something. And so that's a big barrier, I think, is that there's this huge language barrier in technical fields that has different components that I'll talk about a bit, but there's sort of a challenge there already. If you're a deaf student in a hearing classroom or in, I guess this would be like a med school or something like that, graduate class in med school, you have an interpreter and the professor, whoever says something like this, that interpreter actually has to have the knowledge to properly convey this sentence to the student. And so that's a large challenge. Okay, but let's start with the U.S. as a whole and just some statistics on deaf and hard of hearing population in the U.S. So this is, probably, I guess this is now going on like almost 2 decades out of date, but it's probably still similar numbers now. So in the U.S., there's about on the order of 1 million people that are functionally deaf, and functionally deaf means they have like no hearing at all in either ear. They can't hear a single thing. 3 to 9 million people have severe hearing impairment, and there's a definition around that. That it's I don't remember the exact number off the top of my head, but you have a significant amount of hearing loss from. I'm not sure actually if it's in both ears. It requires just one. I think it requires both ears, so you can hear below some level, but you don't have 100% hearing. It's more like on the order of like 20 or 30%, I think. And then 30 to 43 million have some degree of hearing loss, and this group mostly comes from just aging, typically. As you get older, our hearing starts to break down, and so you get a large section of the population having hearing issues as they become older. But out of this group, the 1 million that are functionally deaf are likely ASL users. And then the 3 to 9 million, there's a large component in there that are probably ASL users too. And the statistics are there's large error bars on these things, and that has to do with how the census actually asks about this stuff. They don't really ask about this in an accurate way, so it's a little bit difficult to get info on this. But let's just look then at the U.S. physics and astronomy faculty population. And so in the U.S., there's something like in the order of 1,000 astronomy faculty in the U.S., close to 10,000 physics faculty in the US, and then 24,000 faculty for mathematics. So clearly math is the largest. But if you take those numbers that I showed on the previous slide and you just project them to the US population, you can sort of ask how many faculty would we have that are functionally deaf, have no hearing whatsoever? And in astronomy, it's like 3 or 4. So it's a small number, but it's a meaningful number. But in physics and math, it jumps like way up, right? It's 28 in physics and 72 in math. And that's just the ones that have like no hearing whatsoever. And the severe hearing group, though, are larger numbers. And so you're in the order of tens for astronomy, but then you jump into the hundreds for physics and mathematics. And this isn't even including, the aging effects. I'm leaving that group out completely. And then you can ask, like, how many faculty do you know that are deaf in astronomy, physics, or mathematics? I know 1 in mathematics, I know 0 in astronomy, and I know 0 in physics. Doesn't mean that there aren't some out there that I'm missing, but I don't know. The numbers are not there. You can also then ask about the graduate students, and graduate students are like similar numbers. Typically because, a faculty member might have on average 1 graduate student. So in astronomy, there should be like 3 to 4, fully deaf, physics 50, math so closer to 70. And again, you can ask yourself, like, how many graduate students do you know that are like fully deaf? How many are, severe hearing issues? And the numbers aren't there, although the numbers do increase. So I do know some in this bin now, so but certainly not like 50 in physics. It's more on the order of like 1 or 2 in physics. Math is actually done, I think, the best historically for this, and this might be because they keep the best records. Honestly, I'm not totally sure, but math does do a really good job keeping records and genealogy and this sort of thing for math PhDs. And so there's a paper by a Johns Hopkins faculty who's deaf, who looked back through 1885 and was able to identify 22 math PhDs worldwide. And so this is now worldwide. This is not even in the US. 10 of them were functionally deaf, 5 had severe hearing impairments, and 7 were hard of hearing or identified as hard of hearing. And so for the entire world rate, it's something like 1 every 3 years. But your predicted rate is something like much higher in the US. So it's math is like having some success, but it's only having a very, very moderate amount of success here. And so that's interesting, right? Because thinking about it like now, I mean, what does it require to get a PhD or to become a faculty member? I mean, it requires a lot of study at a university. I mean, just getting through a bachelor's degree is potentially problematic for deaf and hard of hearing students. But then you have to go into graduate school, and graduate school in technical fields, it's, you know, the knowledge there that one acquires and that the faculty have and have to transfer to students is highly technical. And so you can already imagine some of the challenges, like, you know, who's going to be your advisor? You're going to have if it's a hearing person, you're going to have an interpreter there with you all the time. You're learning in these classes with an array of hearing faculty and very technical courses. And so again, like, the interpreter's there with you, you know, doing miraculous jobs, but they don't have the background in this. And so, you know, there's some very serious challenges, and then you have to publish, and then if it's like physics or astronomy, you have to go do a postdoc, and then there's very few faculty jobs that are even available at any given time, so there's huge competition. And so there's a lot you'd have to go through as a deaf or hard of hearing student to emerge, you know, at the end of the thing with a faculty job. And so some real challenges here. But that being said, our field, astronomy in particular, is, you know, has this like really rich history of what I would say like famous astronomers who were deaf and hard of hearing. And most people, I think, would you know some of these people on the slide, but would not necessarily know that they lost their hearing, or they were born deaf, or that would even associate them with being deaf. Particularly Annie Cannon, Henrietta Leavitt. But there's also like John Goodricky, you know, so there's some like really famous examples that go up to like the turn of the century and a bit after that, but then really nothing since then, or very few since then. So again, this points to there's, you know, something going on, like, you know, Annie Cannon, I mean, I don't think at the time you had to go through the same process you have to go through now to do work in astronomy, right? You don't probably have to get the PhD. You didn't have to get the PhD back then. You didn't have to become a faculty member. You didn't have to do postdocs. You didn't have to do all this training. Now there's a you know, a training pipeline that's in place that is tough to navigate. But we do have this nice rich history in astronomy, and so that's quite nice. But so there's barriers to access, and this is just a few of them. These are the ones I think are sort of most important. There are probably others too, but the first one is just large communication barriers, right? And you know, between people who like use American Sign Language as their primary language, and those that don't, who are, you know, who speak spoken English. There's already a barrier there how you communicate. There's things you can do. There's limited technical signs. This is a large challenge, actually. So if you talk about physics or astronomy, where it's a very technical field and the language is quite precise for a reason, most of that language, that technical language, doesn't have a sign, an equivalent sign in ASL. What you would either do is you would sign the concept, you try to show the concept for that particular word, but that, you know, requires more time. The other thing you can do is you can finger spell, which is just spelling out the word, but that's actually pretty terrible in terms of it. Just there's a lot of eye strain that's associated with it. The equivalent for hearing people would be is if I actually spelled out every word in my sentence, or every technical word in my sentence. So if I was talking about, I don't know, plasma physics or something like this, I would spell out the word plasma, and I would spell out like anything else that was technical. And so the sentence would just become bogged down. Your ear would really have to listen to the word to try to figure out what word I'm actually spelling. It's the same thing with sign language. If you're finger spelling the word with just the letters, then there's a lot of eye strain, and you have to like try to figure out what that word is in the moment. And so and that requires you actually knowing what the word is, right? So you can finger spell the word all you want, but if a student doesn't know what quantum entanglement is, they can know that the word's quantum entanglement, but they won't actually know what that means or get any knowledge associated around that. So that's another, the limited technical signs in the field is another barrier. a third barrier, which I think is you see across a lot of groups, underrepresented groups, is that there's no sort of comparable role models, right? There's no deaf faculty, so there's no one to get inspiration from. There's no one necessarily to go work with. There's very limited resources on that level, so it's tough. It's tough for someone to see themselves as moving up this ladder and eventually envisioning themselves in this position if there's no peers that are similar to you, and so that's a barrier too. And then the last one, interpreters are, they are actually phenomenal. And I'll talk a little bit more about interpreters later. They do heroic jobs, but they don't come with STEM backgrounds. It's very rare for an interpreter to ever have a STEM background. And that's because what they do is actually quite skilled. So they have to train for a lot of time in their own craft. And they typically come from, bachelor programs that are like liberal arts types things. So they're very good at what they do, but they often have very limited science knowledge at all. And so that's an issue that can be addressed in different ways, but we do need to be cognizant of that issue. So let's talk about American Sign Language. So the first thing that's like fascinating here is it's one of something like 300 manual languages. And that's like, I mean, when you think about it, it sort of makes sense, right? Spoken languages, there's at least there's something like an equal number, maybe more. I don't know the total number of spoken languages in the world, but it's large, right? And so manual languages develop the same way in pockets all across the world, in deaf communities all across the world. And so the fact that 300 of them have emerged, or something on the order of 300 of them have emerged across the world, should not be shocking to anyone. It's interesting because once I started to get into this, and in our field we travel all over the world, so, which is nice benefit. But when I would travel somewhere, I would actually I would start noticing people signing in all these countries I've been in, but I maybe hadn't paid attention to in the past. And so every time I take a trip now, I've seen someone signing somewhere because I'm just cognizant of it, and my eye just notices it because that's what the eye does when you're immersed in the deaf community. And so like I was even in I think like Morocco, I saw people signing presumably in Arabic Sign Language in Morocco, and like China, and like all these other places. And it's just it's fascinating because it's all these different diverse languages. I have no idea what they're discussing or signing about because I don't know the language, but it's just sort of fascinating to think that there's not like one sign language. It really is like geographically confined, and there are a lot of these manual languages. But American Sign Language is, generally thought to have originated in Connecticut at the American School for the Deaf. And it has a lot of French Sign Language and British Sign Language in it because of the founders of that school came over from France. And so there are similar components. So like BSL, British Sign Language, I can pick up certain aspects of it when I watch it, or at least enough to figure out like, okay, this sign is this because I understand this part of the signing, but I don't really quite understand here, but I can sort of infer what it is. So BSL, like I can pick some stuff up. Same with French Sign Language. There's some aspects of it that are similar to American Sign Language. For American Sign Language, though, there was really this like critical foundational work in 1960 that was funded by actually the National Science Foundation by Stokey, and it established ASL as a formal language with a completely unique syntax and grammar. And so before that, it was just looked at as like, I don't know, some mishmash or like maybe not really a formal language, but like a way people were communicating. But this seminal work like really established that as a formal language. And it does have a syntax, it does have a grammar, and there are rules to it. And so so that's fascinating already. One of the examples I sometimes give, and as a hearing person, it can be a little awkward when you're learning the language. But the placement of adjectives is opposite. So like you'd say in English, you'd say like the blue book, but in ASL you'll start with the the concept, and then you'll narrow down the attributes of the concept. So you'll say like book blue. And so when you're signing, so another example is like same time. So same time, but when you sign it, you're saying same time. So you're doing time same. But if you're voicing while you're signing, you train your brain to map it the opposite way. So when I say same time, I'm mapping this to the phrase same time in my brain. And that's sort of a fascinating thing. So it's a little bit challenging, but it comes along with some of this stuff. So there's a unique syntax, there's a unique grammar, and it's a formal language. It is a language. So another sort of milestone in U.S. deaf history, I think, would be the signing of the Americans with Disabilities Act. And this was signed into law in 1990 by President Bush. And it was authored by Tom Harkin of Iowa, but it prohibits discrimination based on disability. It's similar to the US Civil Rights Act of '64, and it requires basically employers to provide reasonable accommodations to employees and others who need accommodations. And there's some fuzziness there. The reasonable, I think, stems around the cost typically. So my students in particular will run into this sort of thing when they go to conferences, right? So this law requires the conferences, for instance, to pay for interpreters or to pay for captioning services or these sorts of things, as long as it's like reasonable. So if the conference is a large one and has a reasonable budget, it's typically no problem. It's a very small conference with like no funds. Then typically like we would, NTID would try to come up with funding for this sort of thing for a student to go, or I would, through a research budget or something. So the reasonableness has to do with, I think, you can't require, them to take on debt or to go bankrupt or something in this process. But if they have the funds, they have to do this required by law. So, and again, it's mostly with getting captioners for a conference or getting interpreters for a conference is where I and my students encounter this the most. All right, let's talk about U.S. higher education institutes for deaf and hard of hearing students. There are two big ones in the U.S. There's the National Technical Institute of the Deaf, which is part of RIT, the Rochester Institute of Technology, and we are in upstate New York, Rochester, New York. And then there's Gallaudet University, which is in Washington, D.C. These are two very different universities. RIT and NTID's philosophy is to accommodate communication preferences. So we have students across the spectrum here, where they're fully deaf, they're native signers, they're coming here. Sign language is the only way they communicate, but we have things going all the way down to the severe hearing loss category, where like they have some maybe, I think for us, for NTID, it has to be below 30% hearing loss in both. You can hear up to 30% in both ears, or lower, maybe it's 25. I can't remember the exact number, but we have students who have a little bit of hearing. We have students who rely more on lips and lip movement, or some spoken word and sign language. So we have everything in between. It's a very, very diverse group of students that have a ton of different communication preferences. Even within sign language, there's formal American Sign Language, but there's all sorts of like, signed English, where they've learned not American Sign Language, but they've learned signs that are used in American Sign Language, but they're signed in spoken English word order. And there's everything sort of in between. So when students come, they come with like whatever they come with, and our philosophy is to accommodate those communication preferences. Gallaudet is ASL only, and Gallaudet is a liberal arts school, whereas RIT is a research university. Another big difference between them is we have physics and astronomy degree options here at RIT up to a PhD program, and Gallaudet, last I checked a year ago, I think has no physics or astronomy options there. So that's sort of interesting. So really, NTID is set up for if you wanted to have a pipeline of students going from bachelor's degree programs all the way up to getting their PhDs and then going on, like we have the PhD programs and we have the infrastructure to do a lot of these things here. Now, NTID is its own fascinating history. We had the 50th anniversary of it a number of years ago, but it was established by the United States Congress in 1965. And here you can actually see President LBJ signing it into law. And it's really, at the time, it was designed to be sort of, I think, like one of the preeminent deaf educational institutes in the world. And today, I would say we are. We have a large number of students. We have about, in any given year, around 1,400 students that are deaf and hard of hearing. And that's about, it fluctuates, but it's about 8% of the RIT student body. So that makes like RIT already a very diverse school in my mind, because you walk across campus and you see students, you see hearing students signing with like, friends they've made. They came to college, they never thought they'd pick up sign language, but they found, a deaf friend and they started learning it, and then they're just like walking around signing. And so you really find this nice mixture of these two communities, the hearing community and the deaf and hard of hearing community here. We are the largest technical school for deaf students in the entire world. And for us, educational outcomes or employment outcomes, I guess I should say, is the number one thing. We want our students to get an education so that they then can go out into the world and get jobs and do great things. And so one of these metrics that's top for us is the percent of our students that are employed within a year of graduation. And right now it's at 96%. And historically, we're always usually floating in the 96, 97% range for that. So that is our goal: educate our students so they can go into the world and do wonderful things. The other thing is too, we draw a huge international component too, which is sort of interesting, but we have students from like all over the world, and we have students from like all 50 states come here. So we do draw like the top deaf students, I would say, from all over, and it's a nice pool to tap into. So like I was saying, there's some actual really unique possibilities here at NTID. And some of those has to do with the course offerings. So for instance, we also have a large astrophysics department here. We've got 16 faculty currently. We typically have somewhere around 35 to 40 graduate students at any given time. And then we have like 10 or 15 postdocs. And of course, we offer master's degrees and PhD degrees here. So the infrastructure in place for the graduate astro program we're already a very large department, I would say. But what makes us actually really unique is I think we are tops in access services probably in the country. RIT itself trains the most interpreters in the US. And we employ huge numbers of interpreters, note takers, captionists, counselors, and getting students into co-ops and do all these other things. So I don't know if I put this in this talk or not, but I typically have a slide that shows how many interpreters. I think it's like something like 155 interpreters on campus, and it's like 400 note takers, like it's like 200 captionists. I mean, it's like the numbers really blow you away, and especially when you add up all the hours these people work and you show the total hours in a given year we do to support, and it's like some huge number. So I think. I mean, I don't know every single university out there, but it would be hard pressed to name another one that does as good a job as we do in terms of access services for students. Anyway, so with access services and with PhD programs in physics and astrophysics and other technical fields, the goal is, it should be to provide a pathway for deaf and hard of hearing students to advance in the field. So that's sort of like a grassroots effort. Just because there hasn't been a pathway so far. So how do you do that? You really have to start at the bottom and work your way up. And so that's what I've been doing for the last, 6 years or so that I've been here on the faculty, was sort of develop courses, get undergraduate students interested in research. And we're sort of seeing the fruits now where some of those students are going out into PhD programs and graduate programs. and more undergraduates are coming in wanting to have research experiences and major in physics and major in astronomy and these sorts of things. So it's starting to bear fruit, but it's been it's a slow process at the beginning. The first thing though is that teaching at NTID, I wanted to share some differences. I mean, many of you have probably taught in a course or courses all the time in traditional like classroom settings, and I wanted to give a little bit of background on how teaching in a deaf and hard of hearing classroom is different. The first is like it's very diverse in terms of the students, both in terms of their backgrounds and communication, and again, sort of you range from the fully deaf to some that have some hearing and ability to hear, and you realize some unspoken word too, and not just sign language. So often what I end up doing, although not all the time, if it's in a large classroom and I have students that require my voice but also require me to sign, is I end up doing both of those things at the same time. And that is a very taxing thing to do. And so, you teach a course for an hour and a half, and afterwards your brain is just drained. You hit a wall because it requires a lot of energy to teach in two languages at the same time. But then the student backgrounds can be very different. I mean, you have students who come from, they were isolated. They were the only student in their class in a mainstream setting and, somewhere in a rural area, somewhere in the country. To those that are were educated at, deaf schools or deaf K-12 environments. And so you have, when students first get to campus, there's a large number of students who've just never known anyone like them before. And so suddenly you put them in a freshman class with 300 or 400 students just like themselves, and it's like a whole new world experience for them. And so you have to keep that sort of stuff in mind too. And then again, because of those backgrounds and because of how they've been educated up to that point, I mean, some of them may read English really well. Some of them may actually not read English much at all. And so all of our students, when they graduate, they have to both sign and they have to be able to read and write in English. And so some students, it's bringing up those skills, and others it's they're ready to go and they just go. Now, deaf students just generally are extremely visual students. I mean, it's the sort of thing is if they can see it, they can understand it. And so that's the only thing. And so a lot of my thinking about how I teach and when I'm preparing a content or something is built around the visual aspect. Like, what can I do to visually show this? And the more you can do there, the better the outcomes are for the students typically. Now, formal lectures. So let's say it's, I'm teaching a Physics 1 course, and I'm, the stuff you have to cover in there, and you're standing in the classroom and there's a lecture component to it. The classroom style and the lecture style and how I manage that environment is very different from how you manage something in a hearing classroom. The first sort of thing is that the students all have to have direct line of sight to me. So I would be standing in the center of the room, and then the students would be in a semicircle, a half semicircle around me, so that everyone has not only a direct line of sight to me, but they have a direct line of sight to every other student in the classroom. And the reason that is because if a student asks a question, they're going to raise their hand, they're going to stand up, everyone's going to look over there, and they're going to sign whatever or ask their question. And then, and if it's me to respond, everyone's shifting their gaze towards me. So you have to have these line of sight so that everyone can see everyone and the communication doesn't suffer because of that. But that's not the only thing. Some of the other stuff is that, think about yourself. You might have this habit. I had this habit when I started, and it took a little bit of time for me to break myself of this habit. But I would walk up to the board and I'd start writing some equation there, and I'm facing the board and I'm just talking while I'm writing, right? So you can't do that anymore because A, I'm not signing to them, and B, talking to the board doesn't make any sense in this environment. So what you have to do is when I turn to the board, I totally silent. I will write whatever I need to write, and then I will turn back. I will watch their eyes, right? So they have to have time to actually look at what I wrote. And then when I notice all of the eyes coming down, that's when I will go forward. And so you might not have actually noticed this, but on the second slide where I was doing this, or the third slide where I had that quote up there, I watched the few people that I could see in the videos up here, their eyes, and I waited until I could tell that each of you were done reading it, and then I proceeded. So that's another example of that. You have to sort of give the students time to actually read what the content is. If I was giving this type of talk to a deaf and hard of hearing audience, I would not do what I'm doing. I would go to a slide first, and I would just sit there and let it be so people could read the information on the slide. Then I would expand on it and follow up. So even in giving a talk, it's different. And then, so at RIT, the students can do a couple of things. So NTID has degree programs that range from actually associate degree level programs all the way up to master's level programs. And it depends on what major it is and this sort of thing. But then for a lot of the technical degrees, like for instance, the master's, the PhD, or even the bachelor's in physics, they would take the bachelor's in physics through RIT in their college of science, which would mean that you're going through most of the hearing classrooms and you're having interpreters be placed in there. And so part of NTID faculty is not just to teach our own courses in sign language, but when we do have a student taking, Quantum 1, the faculty get assigned to tutor those students, to be support faculty for those students. So for instance, this semester I'm supporting several of the advanced math courses. So things like multivariable calculus and this sort of thing. And so the instructors for those courses are running the courses like they normally would. And then for the students that feel like they need some extra support in that class, they come to me, and I have one-on-one sessions with them to bridge these gaps that they have that show up in communication and other things, and support them through that. So my teaching responsibilities are twofold. It's formal, instructor of record for a course, teaching my own courses, and then I sometimes in these support roles where I'm tutoring them in like more advanced level classes, which both are very, very satisfying, interesting experiences. But okay, so some more examples here that I was talking about. I'm going to show a quote, and then I'm giving you guys time to read this. Okay, yeah. So I can tell, like, basically when people are finished. But first thing would be to let the students actually read this, and then we can have a discussion after that. So that's one huge thing you have to keep in mind when you're teaching. I think I already said this. Classroom, all the students have to be in a semicircle, line of sight to see everyone. This is a good one. So every signer has a dominant hand. So just like writers, like, you can be a right-handed writer or you can be a left-handed writer. It's the same with signing. Your dominant hand can be your right or your left. For me, it's my right hand. I'm a right-handed, so it's natural for me to be dominant in my right hand. But what that does is that it means, like, depending on what technology you use in the classroom, it can be awkward, right? You actually have to think about where I position myself compared to a board or projector or the computer if I'm using that, or whatever I'm actually doing. And so, like, it takes some getting used to at the beginning of a course in a new classroom setting, for instance, to get over that, like, to figure out, okay, I'm going to stand here because my dominant hand's here, and so I can point to the board like this, and I don't have to shift my body much, right? So they can still see my body, and I'm not going like this sort of thing, right? Where then your hands get obscured and you feel awkward. So there is some sort of thought goes into, like, how you position yourself in a classroom, so that they can keep that line of sight to you, and the communication can still be happening, and you're not, doing weird movements to block that communication. And this one is really funny too. I think this was the first or second time I was teaching a course, and I had a student at the end of it thank me for shaving. And it's really funny because I don't actually grow a lot of facial hair, as it is. So even if I didn't shave, you probably would see my face. But for visual students, facial expressions are so important. That's where they get all of this stuff out. And so my lips, what's going on down here, a lot of information is communicated through this area of my face. And if you have like a huge beard here, you can't see that anymore. And so so that's actually a big part of it too. It's in some ways like expressions just come out. You have to be a very expressive person to in this community here to communicate. And so like it was just funny because I hadn't at the time when the student thanked me for this, I was like, what do you need? And then it clicked. Like he's like, I can see your face clearly. It's great. Like you don't have any facial hair blocking anything. And I'm like, wow, okay, cool. So huge beards are probably not great if you're going to be teaching in a deaf and hard of hearing classroom. Okay, so one of the courses I teach regularly is and it's an intro astro course called Principles of Modern Astronomy. I was offered for the first time in 2013. We cap enrollment at all of our courses around 12 students. Some courses are actually capped at like 8 if they have lab experiences and these sorts of things going on. But most NTID classes are capped at enrollments of 12. And that again is because of the classroom setup. Like you have to be able to see, you have to, have this interaction with the class and the instructor, and it just above 12, it just breaks down and becomes not so great. But the course goal here is one that's like most intro-astro courses: explore the cosmos, learn scientific methods and techniques astronomers use, and study the universe and humanity's place in it. And so 2013 was the first one, and we're 2021. So like it's been going for 7-8 years now. This is my first class. Actually, I love this picture because it just so happened. So in Rochester, New York is home to Kodak Company, which was founded by George Eastman, and they have this huge museum of at his mansion where it's like. They have like one of the largest photography collections in the world, one of the largest movie collections in the world. And they had an exhibit at that time on the history of space photography. And Kodak cameras have been in like, Apollo 11 to the moon. They've been in like almost all of the major NASA observatories. And so they had this whole exhibit on the history of space photography that just happened to be happening that fall. And so we went there and they could see like all these things we've been talking about in class, like the actual like huge photos of these things, and that was just a really, really fun thing to do. Okay, I should probably speed up here. I'm going a little slower, but part of this class is that I actually use it as a testing ground too, to vet and measure different educational strategies to increase learning. And so we actually run experiments in the class with the students and sort of measure things and publish papers on scientific education. And so this is sort of something I do with a colleague of mine, Dr. Jessica Trussell, who's also a professor at NTID in the Masters of Science program for our students who are going to go on to be like high school teachers. They get master's degree programs from NTID. So one of the first studies we did was, in one of the more successful ones actually that I use in my classroom all the time now is teaching about morphemes. And so a lot of deaf students are delayed in their English reading, and certainly in their scientific literacy. They're just delayed because they just haven't had a lot of exposure to it. Typically, they've probably not had a lot of exposure reading English. And so the idea was like, how can we boost actually their knowledge of scientifically technical words? And if you think about it, like most scientific words come from like Greek and Latin suffixes. So if you sort of know the Greek and Latin word, you can sort of infer the meaning, even if you haven't seen it before. And so what we did is we taught morphemes for all of the technical language in the class. And so here's an example: constellation. So they would learn like con means like with or together, stella means stars, and tion means like the state or condition of. And so if you know those things, you can sort of get it. It's like a bunch of stars together in some state. And then constellation makes sense. Okay, here's Orion, here's this, these are constellations. And what we do is, because we have small numbers in the classroom, we can't do like large population studies, but what we can do is we can do what's called single case intervention studies, where we test each student against themselves. So we measure a baseline competency for them of their knowledge for some period of time until we get a stable baseline. And then we teach the material to them in a targeted intervention, and we measure until they get mastery of it. And then after that, we test them later in time to see if the mastery is maintained or if they lose the knowledge. And so what we found for this is, if you teach morphemes for scientific concepts, you can get that ramp up in mastery, and they can actually get a lot of information from it, but then they can keep it too, for the most part. And so we published a series of papers on this sort of thing in various journals over the last few years. But that's something I do now, is because a lot of the students that I see just don't have this ability to read scientific words or even infer or guess what they are. And so if you can teach this to them early in an intro astro course, then when they go to their higher level courses in their STEM majors, it'll be easier for them because they'll be reading from biology books, chemistry books, physics books, and they'll be able to take that knowledge with them and use it to infer meaning of things they haven't encountered before. Another thing that I'm also collaborating with Dr. Trussell on is, I just got a big award, this is 2 years now, from the Gordon and Betty Moore Foundation. And Gordon Moore, I mean, many of you probably know who he is. He's one of the founders of Intel, and he's, Moore's Law. So, but they fund a lot of stuff in the San Francisco Bay Area, but they also fund science work and special projects. And they funded this project, which I'm PI of, which is called Lost in Translation: Removing the Most Significant Barrier Preventing Deaf Participation in STEM. And so the reason that I pitched this project to them, and I think they were so interested in it, is I noticed something with my own students who are doing research experiences with me. We'd have them present at a conference, even here on campus, right? And there'd be some talk going on or some other student presenting. And the one of the examples that comes to mind is there was a student giving a talk on a three-body problem. And so I'm watching the interpreters, and when they're talking about the three-body problem, which is or three bodies gravitationally interacting and orbiting, when I watched the interpreters to see how they signed this, they signed three people are having an issue with each other. And so it wasn't even in the ballpark. So that's a problem, right? That's a huge problem already. And again, I mentioned that, in order to actually properly interpret something, you have to understand the concept. And that's because you're not just picking the signs that matches the word, you're mapping the concepts. You have to sign the concept. And so that cell division one, what is the concept? It's like, it's a cell is splitting itself in half. It's making copies of each other. So you have to at least have that knowledge to be able to conceptually sign it. You don't just sign the word cell division, you sign the concept happening. And so in physics classrooms, this is an issue too, because again, a lot of these interpreters don't have strong STEM backgrounds. Now, there are some that have been sort of there for a long time, a year or something, or many years, and they sort of develop it through osmosis. But most don't have it. So our idea is to make very short 3 to 5 minute conceptually accurate signed physics videos and to actually test them in RIT classrooms. And so and then the interpreters can use these, they can watch these before they actually have to go into the classroom for that particular lecture. And as part of that, there's a standardized process for technical vocabulary. Here's my colleague, and she's going to show you an example of what it is. So she's saying acceleration. Remember, physics has vocabulary that's all the same. The sign is what? This. So the sign for acceleration is this. Okay, so we introduce the technical vocabulary in the same way for all of these videos, so the students will then cue into their brain, okay, boom, this is the sign for acceleration. This is how I'm understanding it. And then the conceptual vignettes are like built around single concepts. So right now she's talking about a Twizzler. She's like, Twizzlers, they're candy, they look like this. If you measure Twizzler, what's its measurement? Let's say it's 8.8, but 8.8 what? 8.8 feet? 8.8 kilometers? No, it's crazy. 8.8 centimeters. And so this is just one part of one of these conceptual vignettes about units and measurement. And each of these will have, we're building these things actually at the moment. Each of these have some sign component to them. They have graphics, they have visuals, they have movies, they will have captioning, and they will have signing through the whole thing. And it's a huge project. Just to give you an idea of how this is a storyboard script we have for a concept around distance and displacement. And so, in the black is the English, in the blue is what's called glossed sign. So we're sort of sketching out how we're going to sign this. And then in the red is like videos and graphics we will show to support these things. This is just about 1/3 of this concept, but it's an enormous amount of work to actually think deeply about a particular concept and get it down to its most basic thing, then communicate it in a second language with also supporting visuals that then the students will have a very clear conceptual understanding. But our thought is, and we'll start testing in the classrooms actually in the fall. COVID actually delayed us almost a full year because we went online and the whole thing was a disaster. But we'll start testing in the classrooms in the fall and actually measuring whether this impacts their outcomes. I will say that in my course this past fall, I used all of this stuff. I didn't use the videos, but I used the language and I used the conceptual way we developed for all this. And I saw the letter grades go up a full letter grade when I started doing this. So I think this actually will have a big impact. I'll hurry up here. I guess I'm already at an hour. Sorry, Jake. Just a couple more things to quickly mention. I also co-PI of a deaf RAU program at RIT, and these are for students who are undergoing the deaf cohort experience. And actually the way we did this is we have people from any science field. So the NTID faculty in my department are like chemists, biologists, physicists, astronomers, mathematicians. And so we pool together to have an RAU built around mathematics, where each of us is doing some mathematical technique in our particular discipline. And here's some pictures of students from our RU programs, deaf students from our RU programs. And here's sort of the students that I've supervised, deaf students I've supervised on projects up to date. And I just made offers to 2 more and they've accepted for this summer. So I'll have 2 more undergraduates this summer. The top person here that I wanted to highlight is Brianna Harold. She's a graduate student of mine right now who actually went through our Bridges to the Doctorate program, and she's doing a PhD in computing and information science. She did her master's with me, and now she's going to do her PhD with me on a machine learning topic. So, and we actually just got good news last week. She won a prestigious award from Google to support her studies. So that's great too. But the other 2 here that are highlighted underlined here, these 2 are in graduate programs at the moment. And actually some of these other ones might be too. I haven't updated this in about a year, so I have to check. But so you can see the students are coming in, they're having these research experiences, and then some of them are going on to PhD programs. I should say David's in a PhD program in optics, and Amy's in a PhD program in biology. And the last thing I'll do is just to embarrass Jake here. Jake and I did a project, which is called Astrodance, which was sort of this like art and science sort of collaboration to develop like a dance that would tell the story of the hunt for gravitational waves. And this was all developed and done before the announcement of gravitational waves, the discovery itself. And so Jake and I worked on this project, and it toured around the northeast of the US, and we published it in a journal recently. And I'll just skip all this stuff. You guys can read the paper if you want. It was a fun project. And it was an interesting and unique project too, I would say. So I asked Jake more questions if you have questions about that. And the very last thing I wanted to also advertise is we do have a Bridges to the Doctorate program here that's funded by the National Institutes for Health. And I'm the PhD readiness director for this. So we have students who are coming in, they're getting their master's degree, and we have a support team for them that's then helping them on their way to applying for graduate program. And so many of our students here have gone on to PhD programs in like microbiology, immunology, neuroscience, these sorts of things. So even though I don't know those fields, I'm helping out here with getting them ready for their PhD applications. Okay, and then this last slide, some of you probably have had deaf students in your classrooms when you're teaching, and if you do, or if you do in the future, I would just say these is a list of some things that you can think about. It's really important to work with your interpreters so that they get some understanding of a concept ahead of time, so that they have a better chance of actually signing it. Manage the classroom discussions. Don't let people talk at the same time. Be formal with that and strict with that. Personal questions from deaf and hard of hearing students are cultural. It feels a little bit awkward, but like it's purely cultural. And then with your students actually in the classroom, ask them what works and doesn't work. They'll tell you what they need. They're very good at telling you what they need. And so just, take that information and use it. And then if in your materials and your slides, just make things as visual as possible. And that would really help. So these are some agencies that have funded my work, that have supported deaf students. So I always thank them at the end. I'll stop there.
Thank you very much, Jason. I'm sure people have questions after that. I see Ilse posted one, but she had to leave, but I'll ask you in a second.
Okay.
Of course, we had great fun with our Astro Dance project, though I would say that it teaches you a lot more about, in my point of view, how to explain gravitational waves to a dance choreographer than explaining gravitational waves to deaf and hard of hearing students.
Right.
As that was my task.
That's right. It's not easy. That's right.
Are there other questions for Jason? Yeah, Marika?
Thanks very much, Jason, for this very interesting talk about a world that I know too little about. I would have loved to see Jake dance in the Astro Dance project, but I think I'm misunderstanding task division.
I was not allowed to dance.
Too bad. Actually, I have two questions. The first is about something you said about the huge amount of interpreters and note takers, so these support people at the Institute, yet you speak fluent, or maybe speak is not the right word, fluent ASL. And so do your colleagues also teach in ASL, and or the interpreters for when the students go out into the rest of the world, or is there some people do know ASL and some don't, or how does that work?
Yeah, no, that's a great question. Yeah, so if you're a faculty at NTID, at that part of RIT, then you teach in sign language. So all the faculty here teach in sign language. What ends up happening is, because we don't have as expansive as a majors as RIT as a whole does, what they'll do is they'll take some courses here, and then they'll, if they're going on to their undergraduate degree in biology or chemistry or physics or comparative literature or whatever it is, those courses will be principally taught at RIT, and they'll have hearing instructors. So then the interpreters go into those classrooms and interpret for the students in those classes. So if it's me teaching or any of my colleagues in my department teaching, we're all signing, but in higher level stuff, and it would typically be a hearing professor with an interpreter or interpreters placed in the classroom.
I can speak from the flip side of that, as when I taught at RIT, I was in RIT having deaf students in my class with an interpreter. Though I know ASL a bit, I certainly can't do it enough to be speaking at the same time as doing it. Mm-hmm. But I think a lot of the points Jason made about classroom design, it teaches you a lot when you've got deaf students in your class about thinking about classroom design in general and what you're doing. Like mm-hmm. things like talking to the whiteboard is terrible even if you're talking to hearing students.
Right.
Like a lot of the vocabulary things are very important too, like thinking about those morphemes instead of, most people are taught languages as phonemes and how to say words and not how the word was made. I think that's a lot of, certainly true for Dutch students as well, because most of them learn astronomy in English. And so they haven't learned that structure of the word, so don't necessarily know what they mean. And when you see you're in a class and the interpreter's signing a 3-body problem as 3 people having a problem, like a lot of your hearing students also don't know what that means necessarily at this point. And I know that I loved talking in introductory astronomy classes with an interpreter, because when they start having to like frantically fingerspell and start like saying to the deaf students, like, this will be the sign for this word, this will be the sign for this word, and fingerspelling like crazy, I know that also the hearing students don't know what that word is. So then I know that I need to slow down and be explaining to everyone what this word is. Also, because of teaching in America with my British accent, all of my hearing students also wanted my interpreter to learn British Sign Language for when I say words in a British accent. There was one time when I was saying Saturn over and over again, which I should say Saturn in American. And so my American students didn't understand what I was saying. The interpreter did and was interpreting it fine. So the deaf students were okay. And so all the hearing students were like, no, you have to teach the interpreter has to learn Jake's British accent words in sign language so that the deaf students are on this level playing field. So Harrow, you also had a question.
Yeah, I was wondering if, for example, Asian people have an edge here because their concept of language and sentences is not made out of characters, individual letters like we have, but they are brought up thinking in concepts like your 5,000 characters in Chinese. The character is a concept.
Yeah, that's an interesting point. I mean, I've had students from China in my courses, and I've had other students from other Asian countries in my courses too. I've never actually thought to look into that, or at least it hasn't. That's a really interesting point. I don't know. That would be sort of a cool thing to somehow look into and see if that is. But it could be. It could be. I don't know.
Yeah, Marika.
Sorry, just another question, which is a question about more the practical implications for us in our situation. What can we do with this? So I'm not aware of any deaf students or colleagues in the Netherlands. And so it would be hard or, yeah, maybe not practical to start accommodating my classes. But of course, we have it, well, we do a lot of public outreach, and that has a much bigger audience where people, deaf or hard of hearing people, will be. And so I was wondering if you could give some advice on adaptations we could do. I mean, subtitling a talk would be my naive first suggestion, but I understand from you that might be difficult if well, people do not learn no sign language, but maybe not Dutch in our case.
Yeah, I mean, captioning helps for sure. It may not help all cases, but it is a first step you can take. I think in terms of outreach events, one of the things is, if you have the resources and you have the ability, if like people are registering for an event or something like this, to make clear that like, do you like click this box for an interpreter, click this box for whatever accommodation. That way people see it and they can say, oh, okay, they can handle it, and they click it and they wouldn't not register. Whereas otherwise, if you see something and it's an event and you might want to go to it, you have to be very proactive and contact the organizer and try to get it, which a lot of people will just not do because it's maybe just not worth the effort for them. But if there's some way to like make it very easy for them to request what they need to attend the event, then I would have that clearly there on the registration form so that people can access it and not have to feel like they have to do a lot of work to try to go to something. So yeah, that sort of stuff is some, I think, lower hanging fruit people can do.
We've had
Thank you.
years-long arguments trying to make the American Astronomical Society put captions on the screens in the big presentations, or even have sign interpreters. But
yeah, I mean, we've had some success. I mean, I remember the first time my first student went to AAS meeting, and like, he had an interpreter team, 2 people that would like follow him around, and we just got so many comments on like Twitter. I mean, like, especially if they would go into one of the large halls, they'd like go right up to the front and like stand there so everyone can see them, and so that opens a lot of people's eyes and just makes it more like a more normal thing. It's sad in a way that it's like, oh, this is such a cool thing that I'm just seeing for the first time here. And like, that's a problem, right? So
and it does vary vastly between things, because I think Jason remembers my student Grayson, who worked on education technology projects with me. And
yep.
we went to the International Science Technology Education Conference. And at that conference, we had 2 interpreters with us the entire time, day and night, everything we wanted to do during and after the conference, following us around and participating with us. And then we also went to the National Science Teachers Association conference, and we would have to be hunting for an interpreter like 10 minutes before a session where Grayson was going to present in, because they've got 2 presenters, 2 interpreters the whole conference. And you are then like, no, we need one of them now because he's actually presenting.
Yeah, yep. There were challenges.
Yeah, and I think that's like part of those barriers that you want to try and exclude the barrier by making that easy up front, but then actually following through on it. Otherwise, people are going to choose not to go to that kind of conference really quickly. Any other questions? I see people leaving. I'll get you to answer Ilse's question, which was like, about how new science are developed. I think you started talking a little bit about it, or hinting at it, and how can we as a community engage in that?
Yeah, so that's an interesting question. So so for the more project that we have now, so first of all, I should say there are some signs that are, you know, commonly used that are completely fine. The goal of that project is not necessarily to develop a whole bunch of technical vocabulary. We do it where we have to, I think. But we have a whole entire team that includes like linguists, members of the deaf and hard of hearing community, stakeholders, people that we have review it. And so we think a lot about like, what's the best way to do this when you introduce a new sign. And so things like accelerate, actually, I'll give one example. So our sign for velocity is like this, right? Okay, so this is our sign for velocity. And we saw the sign for acceleration was this. So this is sort of interesting because our sign for scalar is this. So scalar, and this is sort of like you're setting up a reference point or direction. So you've got sort of this. But the nice thing about it is that you can, you know, if you're talking about a car, you can put the car here and you can have sort of it go at the same speed as the scalar would be, and that'd be the speed of a car. And so you have to think about like not just the technical term, but how it fits into the larger language space around the concepts. And so we think about a lot of that, and we come up, you know, through a lot of these iterations of sort of what our best approaches for that. And then we're going to film these concept videos and use them. And then we're not just going to do that. Then I think we're going to measure in particular how each video works. And so like some of them might not actually work very well. And we might have to go in and say, okay, this one's not working at all, or this part of the language is not being picked up by the students. So language is really organic. So I think like, you know, it emanates from places where it's taught. And so here at NTID, it's going to be in the physics classrooms. Like we can use this language, I can use this language, but it's ultimately going to be the students who are going to like either, you know, absorb it and accept it, or they're going to say, well, this is like not great. Like here's maybe a better way to do it or something like that. And so it is a sort of an iterative process that requires time to develop and grow and propagate outwards. So, so I sort of, I mean, ways to get involved. I think if people are interested in, for instance, feedback on any of these movies we make, I'd be happy to like share them ahead of time and get people's feedback, because, you know, we're trying to get as much feedback from not just like language specialists, but also from physicists themselves. Like, you know, is this a clear concept, or, you know, is this taught the best way we can do it? So happy to share some of these and with people for feedback on that as we go forward in the next year or so here on this.
Yeah, and Dutch Sign Language is very close to American Sign Language.
Oh, is it? Okay.
They just, in finger spelling, there's like 2 letters that are different, which I can't remember. And then
that's great.
like vague little minor differences. So it's very,
very
because they were basing it on French Sign Language, but then also because English speaking is so important, then they really based it on American Sign Language. So the sign language is very American Sign Language.
Well, that's interesting. That's something I wouldn't know. So
Shuka is asking how much international collaboration is happening for these new developments. I think you said a bit about that. because she now says, ask me. Yes, you can ask me and I'll get you in contact with Jason. Or in the International Astronomical Union, there's also in our accessibility working group, there's a subgroup about deaf and hard of hearing and sign languages. And there's also an international spreadsheet of international sign languages. That's this gigantic Google Doc. Some are considered now encyclopedic, but Dutch is not there yet. So we have one word sign. There's a video also of the word astronomy signed in all different sign languages that I put together out of all of the videos that were available there. And we managed to get a Dutch deaf organization to send us the Dutch sign of astronomy, but not really hard. And I can say I am an astronomer, pretty much as I would do it in ASL, but I think we do that first. So Shoko, I just want to ask, do you know Japanese Sign Language as well? As you said, you were learning Dutch Sign Language slowly.
Hi.
Hi.
No, so I started learning baby sign language because I wanted to use this with my 10-month-old. I started doing that when he was about 6 months. And then I quickly realized that I have different options because I'm Japanese, but I grew up in the UK. ASL is very commonly used also in Japan. And then there's the Dutch Sign Language as well. So no, I don't know JSL. And the book that I was using to compare ASL and JSL, it turns out that a lot of what I had just learned from just random bits from the internet had been ASL and not JSL, and they're more intuitive to me, but a couple of things make more sense in Japanese Sign Language. But given that we're living in the Netherlands, sometimes for some things it seems more natural to go directly to the Dutch Sign Language rather than using the baby sign or whatever. So yeah, like I said, I'm quite a beginner in all of this, but I've been interested in learning sign language for a very long time now, and I just had the opportunity a couple of months ago to start that with Dutch Sign Language. So I thought I'd just do it.
Yeah, that's fantastic. I mean, my advice on that would be, take it with like someone who's fluent in the language, who's deaf, and then I mean, if you have an opportunity to do that in the future, that's typically the way to go, because you'll get more of the immersive experience, more of the correct interactions. But yeah, that's great. Like, it's fantastic.
Yeah, I mean, and the thing about Dutch Sign Language is that Jake, if you say that it's very similar to ASL, or do you mean that the whole of the sign language is really close to ASL? Because okay, cool. Well, I'm going to come and talk to you
too, because a lot of the ASL sentence structure is based on French as well, grammar.
Right, okay.
The Dutch like that too, so they're really very similar. Did you request a book from the library? If you did, it's back there now, because it was in my office.
No, I haven't.
Somebody did this, so Jason may have had motivated someone to learn Dutch Sign Language, because I had one book in my office requested back to the library after me having it for a year. Just days before your talk, so I'm very there's some motivation going on.
Yeah. No, it's I mean, I personally don't know anyone who's deaf, but I know that in my neighborhood I've actually seen a couple of people sign, and I thought, oh well, I don't know them personally, they live on another street, but also I've come across people signing in airports and thought that's really cool. So I shared the same experience. And also just like there are pros and cons. I mean, not pros and cons, that's not the right way to put it, but of course, oh, my baby is coming my way. He can crawl pretty fast. Oh. No, I mean, one of my husband's former colleagues, she's not hard of hearing or deaf, but her son was born deaf, I believe, and her daughter is not deaf, but she learned sign language when her son was born. And so, yeah, she's probably the one that I would go to for some more inspiration and to actually practice. But yeah, I do wonder about mixing languages a little bit. I don't know. my first motivation is to be able to communicate with this guy before he can talk. And then secondary to that is anything that can come out of it. But Jason, thanks so much for your talk, because I find it really fascinating to hear about all the efforts going on at the institute that you're at.
Yeah. And I will thank you. I'm just going to end the live stream right now, but we can keep talking if you want to. But
yeah.